Hi, I'm George K. and this is my father Niels.
Hi.
Welcome back to another episode of Father and Synthesizer. Today we've got part 2 of the Quantum FS synthesizer build. Now, let's talk about some feedback we got from the last episode from Reddit. First is someone asked if we could make the low-pass filter switchable between 12 and 24 dB.
We actually think that's a good idea and we will put that in. Thanks.
Yeah, that shouldn't be too terribly difficult.
No.
And for that we'll be using the on-off switch on the faceplate.
Right.
Then the second bit of feedback was asking why we didn't use any faders, because they are really nice to use, and I agree, yes they are, but
Expensive.
and they take up a lot of space on the faceplate as well.
Yeah.
And we've never really worked with faders before. Maybe we should buy some and try eventually something with faders. And then someone asked why we didn't have patch memory or MIDI CC controllability of the synth parameters. And Niels, that's a bit of a topic.
Yeah,
Let's talk
it
about
is.
that.
We use the essential STM PCB to digitally control the Quantum FS.
Like
And-
for the notes that are played and the two digital envelope generators and the LFO.
Digital LFO, yeah.
Yes.
And we only have 4 analog outputs and they're all used, so no spare. A way around that would be to have an analog multiplexer, but that's something we haven't tried out yet. It's something we might consider for a future project. So thanks for hinting that.
And by the way, the Essential is our own design of STM controller shield, and we have ordered some PCBs from China, what with the Corona and all. We don't know when they'll arrive, but when they do arrive, we will put them on sale here. We'll make a video. Stay tuned. Then another feedback was the sync. Why we didn't have a switchable hard sync, soft sync. And yes, those are on the 3340 oscillators.
Yeah.
But we haven't got them on the faceplate. There was a bit of a mishap with the switchable octave switcher needing another hole on the faceplate to lock it in place. And that was exactly where the sync input was. That was a miscommunication between designer and engineer. We'll do better next time, and there will be a switch matrix for this on the auxiliary panel, which will also host the modulation wheel and all of that. We'll make another video when that comes.
Right.
Now then, what did we do these past 2 weeks? What happened with our synthesizer?
Well, we had started to populate the faceplate.
Last time already, yeah?
Yeah.
But we finished that now.
We finished that and then we started to wire the backside, and that tell you
It's a nightmare.
it's a lot of work. It took up most of the free time we had.
Yeah, the past 2 weeks were pretty much just spent on wiring up the back of the faceplate.
Right.
Who'd have thought it would take that long? It's not that complicated, I thought.
It is. No, it is. Then we also continued to work on the case for the synthesizer. We installed.
Back here.
Yeah. We installed a PSU and the power connector to the outside world, the power inlet,
Yeah, and some
and
of
the power switch, things like that.
Yeah, output. We have a 3.5 jack and a 6.3, so 1/8 inch and 1/4 inch, so you can plug it into whatever fits your setup best, or my setup in this case. So last night we turned on the power for the very first time, and here's what happened. Okay, ready for first power up?
Okay. What do you expect? A big bang?
I expect an explosion and smoke.
I hope not.
Go for it. Oh, there's a light on. There's an LED.
That's a power LED.
Oh.
And I hear nothing.
Why not?
Turn on the other.
Well, that's a disappointment. So as you heard, nothing. But today we do have something. And we did a little video of that as well, me playing around with the sounds that are coming out at the moment. So let's check that out. So basically what we've got here are all three oscillators. I'll just turn this down a little. What we've got here are the three oscillators up and running. They're not perfectly done yet, but yeah, we still need to do some fine tuning. And the filter VCA section doesn't really work yet, and we haven't used the envelope in this. But we have this LFO, which is routed to the vibrato on all three oscillators, and I've just played around with that a little. Sounds pretty cool, I think. Okay, so how did we get from nothing to something? What went wrong between last night and this morning when we recorded the demo?
Yeah, I found that there was a control voltage for the oscillators set to -6 volts, which is a very, very low frequency, so they naturally did do nothing. So once that was fixed, we started to hear oscillation. We had nice sawtooth and rectangular, but on two oscillators we had the triangle wave missing.
Well, it wasn't missing, it sounded more like a square wave.
It sounded really bad and
well, distorted
and pulsating things, really bad. And so I went back to the PCB, and indeed there were bad connections, two exchanged resistors, and one resistor was 30 ohm instead of 91 kilo ohms. Don't ask me how that happens.
We're thinking probably one of the Chinese factory mistakes, because we do buy the cheapest resistors on the market.
We do. It's right from the belt, so what can go wrong, huh? But okay, found
Mistakes
it,
happen, yeah.
fixed it, and
Now
so we
got-
were able to do the very, very first sound demo you just heard.
Yeah, now we've got three working oscillators, more or less, and you spent about an hour this morning calibrating them so they're true 1 volt per octave. And as you have heard, they do sound very, very octave accurate for analog oscillators.
They track beautiful. Really.
Yeah, now we just need to tune them.
Right.
We've got a lot ahead of us. Then turns out the VCF and VCA just don't work. I mean, the VCA does do something.
They work electrically on the PCB, but I might have some errors in the wiring of the front panel.
We have to check that out. We'll get back to you next week.
We'll find it.
Then both VCA and VCF also needed additional inputs, didn't they?
Yeah.
That's also something we did.
An overlook on our side, and
Yeah.
also for the sub-octave oscillators.
that was. You wanna know what he did? In the schematic, he hardwired the sub-octaves to the mixer with no attenuation between them, so the sub-octaves would always be fully on. And that's why you need a musician to help design these things.
And that didn't sound good.
No, so now we've added some attenuators for them, some potentiometers on the faceplate.
Yeah.
And
the last thing,
they do sound pretty weird still, the sub-octaves. They have
Yeah.
some crackling, something.
intermittent failures in
Yeah.
dividing the. So
No idea where that's coming from.
I might have to design a little extra PCB.
That
with
would
the
be a
sub-octave.
1, 2, 3, 4, fifth extra PCB on the back.
It's a prototype. Right, and then we also forgot that the sample and hold needs to be switched to external clock if needed. So
yeah, because that's very important.
Yeah, another pair of wires that goes directly from the PCB to the front panel.
So stay tuned. In 2 weeks we'll have another video, hopefully with a much better sound demo, because the plan is to have the VCA and VCF working so we can use the key step and the analog envelope generator to show you the first couple sounds. That would be cool, wouldn't it?
Absolutely.
So stay tuned until then. Thank you very much for watching. We hope to see you again next time. And remember, stay curious.
This is my house, a place that I can feel safe.